Hello everyone. So in this video we are going to practice some basic assertion questions. So let's begin. So our very first question is that a signal should not have high impedance or unknown value except during reset. So the question is basically that the signal should not have either X or Z values except except during reset. So we are going to write a very simple concurrent assertion for this, and let's begin. So first of all, we will begin with writing our property, and I will name this property. Let's call it uh, p underscore x z rst check. Now I will just end this property. Now I want this to happen. Just a second. Now I want this to happen at the positive edge of the clock. So what I will do, first I will write at the rate positive of clock, and here we are assuming that the clock signal is called CLK. So at the positive of clock, what I will do, I will use dollar is unknown, and let's say the signal is A. So at the positive edge of clock, the dollar is unknown A, which basically means that A should not that which basically indicates that whether A have any unknown values like X or Z or not. So I will just put this 0. So this basically means that A will not have any A will not have any unknown values or high impedance value at the positive edge of clock. But our assertion states that it should not have any unknown or high impedance value except during reset. So what I have to do, I have to do a little modification right here. So I will write here disable keyword, disable if and only. And let's say that the name of the reset signal is RST. So this completes our property, and it says that at the positive edge of clock, the signal A will not have any unknown values like X or Z until unless reset is asserted. So if that's the case, if at the positive of the clock, if reset is high, then we shouldn't care about this assertion. The whole property will get deactivated and the assertion check will not happen. So let's complete our property. So now just let's go ahead and assert the property. So you could just go ahead and write assert property, and inside the bracket you could just write the property. But what I will do, I will just label my assertion. So similar to property, I will name it something like this. I will just begin with A underscore X Z reset check, and here I will just assert the property. Assert assert property, and inside that I will just write the name of the property, and the name of the property is p underscore x underscore z underscore reset check. So I will just write p underscore x underscore z underscore rst check. And I will also write another thing. If the property fails, then it will generate an error. And inside the error, I will just write that uh, a is having x and x or z during posage of clock. So this completes our property. So there are multiple ways of writing the assertions. You could directly write everything, every sequence inside the property section, or the most convenient way is to write the property, then uh, write that property inside the assertion. And you could also divide the sequence inside the sequence block. Then you could write that sequence block inside property, and then you can write that property inside the assertion check. So this completes our property, and now let's begin with other question. So the other question is going to be very simple. Like I have already said that the entire video will focus on very simple concurrent assertion questions. So in this question, I would write, I will write a sequence separately. Then I will put this inside the property in such a way that it will get sampled at every passage of the clock. And then I will put that inside the assertion just to assert the property. So the sequence should be something like this. Uh, the There are two signals. Let's say the signals are A and B. So my assertion is that uh, B should be true 2 clock cycles after A is true. So this is my assertion that the B should be true 2 clock cycles after A is true. And here the name of the clock signal should also be CLK. So let's begin. So I will write the sequence. So here, instead of writing the property directly, I will first write the sequence. So uh, let's write this sequence and seq and a to b. So I am naming my sequence seq underscore a underscore 2 underscore b. Then I will end the sequence. Now I will begin. So the signal 2 should be true. The signal B should be true 2 clock cycles after A. And just hold on a second. This is very frustrating. So I just broke the videos and I just installed few extensions which were becoming quite frustrating because I want to explain everything from scratch, and they were just prompting me suggestions, and I don't want that. So let's resume our question. And here, what we wanted that B should be true 2 clock cycles after A is true. So the sequence is going to be very simple. So inside this sequence, you could not use things like implication operator or anything. So mostly in a sequence block, you will use something like this. Uh, Something like this. So these are going to be mostly used inside the sequence, and for most of the time, I would use property, a combination of property and uh, other property statement, in which I will also just label the other property statement. So let's begin with our sequence. So our sequence is going to be very simple, A, and I will just use this timing thing, and 2 ticks after the A, B should be asserted. So it is that simple. So in property, you will determine that what this hash 2 means. So here I will write a property, and I could call this property anything. So let's call this A2 B, and this time I'm putting B after the name of the property. And here I put B before the name of the property. So these are just your personal preference, but still it is preferred that if you're writing assertions or property or sequence, just write them anything you want, and right after that or before that, you just put one underscore, then P for property and A for assertion. So I mean, in real scenario, when you will be writing lots of assertions, this will help you to manage the code in much and more efficient way, and you could just debug the properties fastly. So I will just send the property, and inside this property I want this property to be sampled at the posage of clock. And here what I will do, I will write the name of the sequence. So this ensures that this property gets sampled at the posage of clock. And here the 2 time delay means 2 clock cycle after the A. So it will check for assertion of B 2 clock cycles after the A. So here 2 just mean 2 clock ticks or 2 clock cycles after A. So let's begin with asserting the property, and it is going to be very simple. I will just write the same thing, uh, A underscore 2 underscore P, and here I will replace P with A just to ensure that it has the same label, and I am asserting that particular property with the label A underscore 2 underscore B underscore P. So here you just have to write assert property, and inside this you just have to write the name of the property, and I will just write else. It will display an error, and let's say that B is not high to cycles after A. And you could also include more details like this assertion failed. So this concludes our assertion, a very simple one in which B is going to be true 2 clock cycles after A. And for this particular case, I just write sequence separately. Then I inside the property I write that at at what signal that sequence is going to get sampled. And inside the other property, I just write this property and I asserted it. So we are going to move on with our other example, and this example is going to use the same sequence. So in the next example, we are assuming that uh, there is another signal which is C, and it says that we have to write a property in which if sequence S, sequence A underscore 2 underscore B is true, then on the same clock cycle C is true. So what it basically means that if A is true, then 2 clock cycles later B is true, then on the same clock cycle in which B is true, the C should be true. So how could you write that? So I will use the same sequence and I would write it in a different way. And I will also, in that property also, I will just sample this sequence at the postage of clock because we want our assertions to be clock synchronous. And what I will do, I will use a different thing, a thing that cannot be used inside the sequence block. And that thing is called implication operator. So there are two implication operators, the overlapping implication operators, which looks something like this. So the overlapping implication operator basically means that that thing is going to be true in the same clock cycle. So let's say if we have a random sequence, let's say the name of the sequence is sequence A, B, and sequence. So if I write something like this, A, B. So if I write something like this, A, then an overlapping implication operator, and B. So it basically means that let's say we are writing a property, and we name that property as A underscore B underscore P. So if I want this sequence to be sampled at positive clock, and the clock signal is CLK, and here I will write sequence A underscore B. So going by that sequence, it basically means that if A is true uh, at positive clock, then B should be true at the same edge. So if this is the case, that A is true at the positive clock and B is true at the same pose edge, then this property passes. Else, this property fails. So this is how an overlapping implication operator works. Now let's move on to the other category of implication operators, and that is non-overlapping. And it is denoted by something like this. So instead of using hyphen, um, you will use equal to, then the same thing, arrow. And the non-overlapping implication operator basically means, let's say I am copying everything, and here what I will do, let's say instead of using this, I will use the non-overlapping implication operator. So this basically means that if A is true at the positive edge of the clock signal, then B should be true at the very same, at the very next edge, at the next pos edge of clock signal. So this is the difference between the non-overlapping and the overlapping implication operator. In the overlapping implication operator, if you put something like this, then B should be true in the same clock cycle, in the same edge, than the A. And if you put something like this, if you put the signals in non-overlapping sequence, then as the name implies, B should be true at the next positive edge of clock. So this is kind of equivalent of this. And similarly, this is the equivalent of this. So either way will work fine. The only difference is that I'm doing something wrong. And the wrong thing is that the implication operators cannot be used inside the sequence block. They can only be used inside the property, or you could just directly write this kind of sequence inside the other property. So it cannot be used inside the sequence block. So this I am doing it wrong. So what I will do, I will just replace it, and I will just write it right here. And I will do the same thing for this. I will just replace it, and I'm going to write it right here. So yeah, so if you are using the implication operators, you should directly use it inside the property. And if you are using the sequence, something like this, in which you are using numerical delays, then you could just use it inside the sequence. So that's how the overlapping and the non-overlapping implication operator works. So here in this, the signal before the operator is known as precedent, and the signal after the operator is called as antecedent. So let's begin with our question number 3. So our question number 3 was that there was another signal C, and in the signal C, just a second. And that signal C should be true when the sequence, and the sequence is SEQ A underscore 2 underscore B, when the sequence, this particular sequence is true. So on the same clock cycle, uh, the signal C should be true. So if I just put this on detail, so it is something like this, that A in totality, if I also go in the lower level and also consider the sequence, then if A is true, then in the next clock, in the next two clock ticks after that, B is true, and then on the very same clock tick, that is 0, the C should be true. So we would end up getting writing an assertion which will check the sequence, which appears to be something like this. So if C is true, then on C there's a single C, and it should be true on the same clock when sequence A underscore 2 underscore B is true. So which basically means this particular sequence in total. So I would just write the property, and I would just write C and SEQ. I am just naming it randomly. You could name it whatever you want, as it is user defined. So I want this property or the sequence to be sampled at the posage of the CLK or the clock signal. And if sequence underscore A underscore 2 underscore B is true, then using the overlapping implication operator, I would write C. So if this sequence is true, then C should be true. And we will end up getting property, a sequence like this. So this concludes our particular desired signal sequence, and I would just write, first I will just label this property, and let's call it C underscore SEQ underscore A assert property, and then name of the property else we will get an error. So it is that simple. So let's move on to another example, and in this example uh, it is going to be very similar instead, but only difference is that C should be true at the next positive edge of the clock. So you could already guess that here um, what particular kind of operator can we use? Non-overlapping operator. So here we will use non-overlapping operator because we want C to be true one clock cycle after B, I mean uh, the sequence A to B is true. So we will get something like this. Our sequence will be something like this. A is true, then two edges after this, B is true, and then one edge after this, C is true. So let's write the property, and let's call this C underscore SEQ underscore P. So I just flipped the name, and this time I also want it to get sampled at the pose edge of clock, and I will just write the same thing, sequence A to B, and I would just use the non-overlapping implication operator. So our sequence is the precedent, and after this we are going to write the antecedent, and in our case it is C. So uh, this is just making this particular sequence, and right after that we will label our assertion, and since we have already an assertion which is named similarly, I will write this A2, and the name of the property else it will throw an error. And C is not true, a clock, a pose edge at next pose edge when is true. So this concludes the usage of same sequence, and this time instead of using the overlapping operator, we use the non-overlapping operator. So This concludes our basic video, uh, and it's a good video just to begin with concurrent assertions. And I just wrote few examples, and the very first example, the very first two examples were very basic, in which in the first one I was checking that the value should not be unknown, and here my condition was that if reset is true, then we don't care about the condition and want the property to get disabled. So that's why we use disable if and only if reset is true. And the other one was just to show you the demonstration of the sequence, the overlapping implication operator, and the non-overlapping implication operator. So I hope you find this video useful, and stay tuned for more and keep practicing. Thank you so much.